Hello guys, today we are going to solve the graph question cost effective travel with no more than k stops. It is medium level question. Let's look at the problem statement. Uh, One day a traveler named Alex wanted to journey from city called source to destination city called distance. Alex had limited budget and only certain number of stops they could make along the way, no more than k determinant. Find the most affordable path. Alex looked at a list of available flights between the cities. Each flight was marked with a starting city, a destination city, and its price. Alex's mission was clear: find the cheapest route from source to destination. With the goal in mind, Alex set off on their quest find best possible deal. This is the question, and constants are from 1 to 100, and these are some example inputs and output. In this question we have a given the flights array with its source and destination with its price, how much price is for ticket, and the stops, minimum stops we need to find with minimum stops. Yeah, let's look at this example. Source 0, destination 3, and k is equal to 1. Source 0, destination 3, and k is minimum stops 1. From 0 we can go 1, and we can go from 1 to 2 or 3, but we have to go 3 with minimum stops. The minimum stop is equal to 1, so we directly go with 3 with the value 100 plus 600 is equal to 700. The minimum cost is 700 for this example, but if we go from 1 to 2 to 3, it will increase the steps minimum stops for this, so we go from direct 0 to 1 and 1 to 3, so k is equal to 1. It satisfies the minimum stops, k is equal to 1. Let's look at the code. We define the function with name find cheapest price and t comma test cases. These are two inputs. t test case as the input and test case list of tuple each contain number of cities, flight, source, destination, and k. This is the result array which is initially empty. We iterate the loop for input values. We have created adjacency list to solve the graph question with the default dict function with a with name adjust adj. Iterate the flights with u, v, and w. U is the source, v is the destination, and w is the weight in flights. We append this value v and w in the adjacent list. It is a directed graph, and initialize distance and v. Distance array with maximum float value. Float infinity used for initialize the maximum value into n is length of array, and distance of source is equal to 0. It it has initial value 0, and q with current weight and current node. Current weight should be 0, and include source in the count. Now we use BFS to solve this question, and we use while loop for while q and k should be greater than equal to greater than 0. Temp distance. Create a copy of a distance to avoid mid-level update. Ensure that update in current level do not affect other node being proceed in same level. That's why we use temp distance. Again we iterate the loop with and popping the value from left side of a DQ, and we get the current weight and node, and iterating again neighbor weight and adjacency node, which is we find here, and we check if the current weight which is we pop from here and the weight from its and adding its weight from its neighbor, it should be if less than temporary distance neighbor, then we assign the temporary distance neighbor value is equal to current weight plus weight, and appending this value again in the DQ, and update the distance. Now we result if the cost is infinity, then we return -1, else we return the result. This is for input handling. Now run the code. It passed all the test cases. Now submit the code. Congrats, it passed all the test cases. I have solved another solution for this question with the Dijkstra algorithm, which use priority queue to solve this question in Dijkstra algorithm. Dijkstra algorithm is useful for minimum cost like this question. It tells us to find the minimum cost for flight. In Dijkstra algorithm, we also build a graph and appending the value of V and prices in the graph of V. The adjacent list is created. Now the source value should be 0 because the current cost always be 0, and the priority queue we created with the current cost, current node, source, and the stops, and we are iterating the priority queue array, which is PQ. Now while PQ, we popping the value with minimum value which is stored in this PQ. The value is popped from cost, node, and stops. If stops is greater than k, then we skip this path because it exceeds the value of k. Stops should be less than k. Now iterate its neighbor, it's the graph node, and for neighbor and price in graph of node, new cost is equal to cost plus price. If new cost less than or money of neighbor means the neighbor value in money array, which is here, should be always be less than. If the new cost value is less than, then we assign the value new cost to the money of neighbor of new cost, and again we push this value new cost neighbor and stops plus 1 to the PQ array, which is here, and we return the result. If the destination has float infinite value, then we return the -1. This is the input code. Again we pass all the test cases, submit the code. Yeah, it accepted.